All right. Happy Friday. We are here for another kind of weekend coding session, and we're going to code together. We started our ship shooter project. So, in class this week, we went over the kind of initial design and we put some pen to paper. We started to develop our ship shooter game. And in this lesson, we're going to walk through how to add movement to our ship. So the goal here is to kind of work alongside me here as we continue to build this game out. And I'm going to provide a little bit of an overview of where we left off and how we got to where we are. So let me go ahead and share my screen here. And this is where we left off on Wednesday. So we started the discussion around this idea of a ship, right? And we're thinking in the mind frame of an object-oriented programmer where we're not thinking as much in code as we are in just what we're trying to solve. So we have this idea of a ship, which is this triangle that we want to be able to move around the screen. So fundamentally, the two methods that we really care about, or the two functions that this ship needs to do initially, is to move and to draw itself, right? Remember, we don't want to forget that draw because it's a fundamental method that we want to be able to express with a ship. So we started this with a basic P5.js program, right? We have our setup and we have our draw. And because we only want one ship in our system, we created this new ship inside of the setup. Now we started this from the perspective of what we called a ship builder, right? We're the one that we're actually, I'm sorry, let me back up. It wasn't the ship builder, the user of the ship, right? We're actually using the ship. So in this case, we're creating a new ship here. So we actually called our builders these with this new keyword, and we said, "Hey builders, come on over and let's build a new ship for me. I want to be able to use it." And we took this new ship and we stored it into this variable we called ship, right? So one of the things to note here is this capital S and the lowercase s, right? This capital S is telling us that we're using the blueprint of a ship, which is going to be a class that we're going to define, and then we're storing a built ship using that blueprint into this variable we called ship. So the perspective right now is that we are using this newly built ship. Now, the only way that we really care about using it right now is to move it and to draw it, right? So we want to do that in every frame of the game, right? So 30 frames per second, we're going to be moving the ship and drawing the ship. So instead of putting that in our setup function, we're going to go ahead and put that in our draw function because that's called 30 times per second. So we see here, we have the ship.move and ship.draw. Now, this is where that idea of dot notation comes in. This is how we call methods inside of an instance of an object, right? So in this case, this is an instance of a ship, and ships are going to have a method called move and a method called draw, right? These are those methods that we defined when we were speccing this game out and thinking about the different functions and properties that we would need in order to actually create the game. So from our perspective of a user of a ship, right, we're just using this ship object. This is really all we need right now. Now, this is where that idea of abstraction comes in. As the user, I don't really care too much about the details of moving and drawing, right? I'm just using those features. It's like me going and buying a drill or using a car and just hitting the gas and turning the steering wheel, or using a drill and hitting the button and it just spins. I don't need to know the internal details of how these things work. I just need them to work. So in this case, I know I need to be able to move a ship and draw a ship. But now we need to take that hat off, and now we need to put the hat on of the ship builder because we need to play both roles here. So we need to actually implement the ship class along with the properties of move and draw. And that's exactly what we did on Wednesday, right? We defined our new ship class and we created our constructor, and the constructor defines two properties. Really only two properties we care about right now are the position of the ship in space. So the position is naturally expressed as an X and Y coordinate. And so we have an X and Y property here inside of the ship. And then we kind of scaffolded out two methods. The first is move, which we don't have anything in it yet. And the second was draw, which is what we filled out in class. So we have this, basically we're just drawing a triangle, right? But the interesting thing about this draw method is that we are using the X and Y property to be able to draw the triangle. And the triangle function takes in one, two, three, four, six, right? Three sets of two, right? Because it's 3 points. So the first point is its X and Y. The second point is the second X and Y. And then the third is the third X and Y. But the interesting point here is that the second and third X and Y are relative to the first X and Y. This is how we're going to be able to move the entire triangle kind of cohesively, right? If we only moved 1 point in the triangle, it wouldn't look like a ship. It would look kind of weird, right? So if we run this program, we should see that we have our ship rendering right in the center of the screen. So this first point right here is our X and Y, which is 200, 200. And then this point and this point are relative off of this. That's why we did this minus 20 and plus 60. And you can kind of think that through and see how we are just kind of offsetting this initial point, right? So that's a little funky, not super important right now, but it is kind of critical, because if we just move the X and Y, then it's going to look weird, right? So for example, if I go into this move method, which is empty right now, but we are calling it, so we are executing this method. If I say inside of here, if I just say this.x plus plus, actually this is going to work, right? It's going to move the whole thing. And if I hit play here, you'll see the entire ship moves. Now, just to give you an illustration, and you don't have to do this piece. If I render this triangle with just this.x and this.y, and then I put some, fixed values in here, say for example 100, 100, 200, 200, watch what's going to happen. It's not going to look like a ship at all, right? We're going to get this 1 point that's moving, and the other 2 points will be fixed in space because these will not change at all. They're not dynamic, right? Let me run that one more time. You can see that 1 point is moving, but these two bad boys are staying exactly the same. So this is why we need this idea of a relative point relative to the X and Y, the initial X and Y, right? So now if we do that, you'll see the entire ship moves. Awesome, cool. So let's go ahead and let's build this move method out a little bit. So we're basically building a controller at this point, right? So you can think of this as like we're making that P5, that PlayStation 5 controller, or that Xbox controller, but we're putting it inside of this method. Now, there are a couple of core programming ideas that we need to express here. We need to make decisions based on user input. So whenever we say, hey, we need to make decisions on something, right? We need to check something and then do something based on what we check. What fundamental idea are we trying to express here? What do we need to use? What tool do we need to pull out of our programming tool set to be able to do this? There's really kind of two, right? The one that I'm poking at here is conditionals, right? We need to be able to conditionally change things in our system based on user input. So there will be some variables that we need to also manipulate once we execute these conditionals, right? So based on what we find, based on the input from the user, we're going to change different properties in this class, right? And a lot of times that's what methods are doing inside of these classes, is they are manipulating internal properties. In this case, the only properties that we really need to change, as we just saw, to move the ship is the X and Y coordinate. But we want to do that based on user input. So we're going to be testing user input, and then based on that tested user input, we're going to change either the X and the Y coordinates, right? So like, for example, if I'm hitting my left key, I'm going to want to decrease the X values. If I'm hitting the right key, I'm going to want to increase my X values. Same thing with up and down, right? I'll just be manipulating the Y value instead. So let's go ahead and see what this would look like, right? There are some functions that we can call in P5.js that gives us the capability to test if a key is down or not, right? So let me go ahead and I'm going to pop into the reference real quick, and let's go ahead down to user input. I think there's a whole input section here. I'm not going to search for it. I just want to see if we could just scroll through and find it. Because naturally you're not going to just know the function to search for, right? So I'm not going to do that. So if we look at IO, we have this input, right? Okay. It doesn't look like there's anything pertaining to the actual keyboard input. Now, a lot of the input here, this is actually has to do with data input, not necessarily user input, right? So like loading bytes and loading data. So we don't really care about that too much right now. Events. Okay. Oh, keyboard. Here we go. Keyboard input. So we have all of these different functions. Now, there are a bunch of different ways we can implement this, right? I saw somebody in class, which is awesome, start implementing this on Wednesday, and they were using some of the built-in functions inside of P5 that are outside the scope of the class, which you could do, but we want to encapsulate all of this, right? We want this idea of a ship to be fully encompassing. So somebody can use our ship that maybe we don't even know, and they could just say, hey, dot move, and the dot move is going to check for keyboard input, and they don't even need to know about it. So this key is down is interesting, right? If we go here and we say key is down, this gives us the capability, and look at this. This is kind of exactly what we're looking for, right? If we look at this example, this is giving us inside of the P5.js draw function here, if key is down, left arrow, if key is down, right arrow, if key is down, up arrow, and then we're manipulating an X and Y coordinate. So this is essentially exactly what we need to implement our controller, right? It's going to be a little bit different because we need to manipulate the property of X and Y inside of our class, but essentially it's the same thing. So let's go ahead and I'm going to actually, well, let's type it out. Let's go ahead and here we're going to say if key is down. And the cool thing about this is that P5.js does have these built-in globals that we can use to check for the key. So this basically just resolves to the key code of the specific left arrow key on the keyboard, right? It's just kind of a convenience thing for us. So when we read this code, we can we know exactly what we're doing instead of putting like 11 in here or whatever it is, right? And then questioning, okay, what is 11? And I have to go reference it. If I just say left arrow, then we know that we're talking about the left arrow. Now, I like in this example how they explicitly said true. We don't have to do that because this will resolve to true or false, but this is kind of more of a, I would say, a defensive programming technique where we're being very explicit as to if it's true or not. So, excuse me, we can go ahead and do that. That's just good practice, right? So let's do that. We'll say equal, equal, equal true, and then we'll open and close our parentheses. And then what we'll do here is, what do we want to manipulate? So if the left arrow is hit, right, that means that we want to move the ship in the left direction, which is the negative X direction, right? So we're going to say, instead of just saying X, we need to say this dot X, because we're talking about the instance of this ship, right? This dot X minus equals, and then we'll subtract it from itself. So this dot X minus equals, actually we could just give it like let's do it in long form. I'm going to say this dot X equals this dot X minus some value, right? And some value can be arbitrary. We actually should make this a internal property. Maybe we call it ship speed, but for now I'm just going to say 10, right? Now this should get us to the point where we can actually move the ship in the left direction. Let's see if it works. So now here, if I hit left, look at that, boom, it's working. I can't move any other direction, but I can move left. And 10 seems a little much. I hit it once and whoa, we're moving a lot. So I'm gonna actually make this more like 1. And there we go. I can move the ship in the left direction. Excellent. Now, I'm not going to do every single one of them. I want to leave the others to you to do at home, right? I'm not going to do 100% of these. This is one of them. You're basically going to do the same exact thing, but for the other three directions, right? So you're going to do right arrow, you're going to do up arrow and down arrow, and you're going to manipulate the properties that you need to manipulate for that, right? One thing I do want to do before I end this video is I want to make this value an internal property. I want to make it ship speed, because we don't want to be typing this one over and over again, and then when we want to change the speed, we have to change it 4 times. I just want to be able to change it once, right? So what do we need to do that? In our constructor, we're going to define a new property. We'll say this dot speed equals 1. Now, this is super simple. All we have to do now is say, instead of 1, this dot speed. Now, it's going to do the same exact thing. We can move it. We can move it, but it's using this speed. Now I can change this if I wanted to 3, right? And now it'll change the speed there. So now, once we have the other 3 conditionals in here, we can change the speed in one location, and it will update it in all of the locations. Super convenient, right? So what I'd like you to do here is get to this point and then add the other 3 directions in this method. And then at that point, we should have a fully working controller for our ship, and our ship should be moving around the screen. Now, of course, not only is there different ways to implement the conditionals on how we detect the keyboard input, there are also different ways to kind of smooth this out. We're not going to go too much into that just yet. If we have time at the end of the semester, we will. There are some interesting kind of maths that we can implement that maybe will create a bit smoother movement. But for now, let's keep it simple and let's get this piece in there. All right. So good luck, have fun, and we will be looking at this on Monday. All right. Thanks, guys. Have a good one.